KCL. Do I know two of three things anywhere for my circuit? I do, at the battery, don't I? I know that the voltage of the battery, and I know the total resistance that the battery sees, so I can calculate the current that comes out of the battery, right? I can say V bat is equal to I times RT, right? That's the battery. And so I can say 18 volts is equal to I times 5.5 ohms. So what's my current at the battery? 3.27 amps. Okay, so now I can write 3.27 amps. Okay, good. So I calculated 3.27 amps. Whatever I calculate, always use that as kind of a launching point to the next thing. So if I calculated amp, think amps, where can I use that to help me? If I calculate a voltage, where can I use that to help me? Okay, got it? So we just calculated an amp. Where can I use that newfound knowledge to help me in the rest of the circuit? I know that 3.27 amps goes out the top. That doesn't help me too much because it splits. But I do know that 3.27 amps go in the bottom as well, and I got a lone resistor on this leg. So what's the current there? 3.27, right? So I get 3.27 amps going towards the battery through that resistor. And now I ask, do I have what? 2 of 3, so I can calculate what is the voltage there. Isn't it 13.1, I think? 13.1. 13.1 volts. Awesome. Okay, so now I just got done calculating a voltage. Think voltage. How will that help me get another part of the circuit? Well, let's think KVL, right? The loop rule. Since I just calculated a voltage, do I know from A to B? 18 volts. So if I go A to B another way, then I should be able to get 18 volts. If I go 13.1 and then up some amount, it should equal 18 volts. So what's 18 minus 3.27? 4.9? 4.9 volts. I got that by KVL. I got it by KVL. Now, again, I know 2 of 3 things. 4.9 divided by 2 is 2.45 volts, right? Or amps. So I get 2.45 amps going through that leg. Okay. I just calculated an amp. What can I use? Can I use that to help me with anything?
Yes.
I know that amps are used in KCL, so is there a junction that what I just calculated will help me determine something else in the circuit? And indeed it will. The same reasoning, I can do it at C or I can do it at D. I'm going to do it at D because there's more room. But I could just as easily do this at C. Okay? I know that coming out of the battery, I have 3.27 amps. I know just from this calculation that this direction, the current, is 2.45 amps. So that means that my current going this way has to be what? Based on KCL. 0.82, right? 0.82 amps. Okay, great. So now I know what? That 0.82 amps goes into what kind of circuit? A series circuit, and we know that the same current flows through each of the resistors in a series circuit. Does that make sense? So now I know this is 0.82 amps, and I know this is 0.82 amps. And so now I know 2 of 3 things. Now, I'm not going to get on you whether you do one or the other, but just follow me on this so that I can make the story straight for everybody, okay? I'm gonna pick this star here. So 4 times 0.82 is how many volts? 3.2. Exactly, right? 3.28 volts. Okay, I just calculated a voltage, and so what can I use to help me get something else? KVL, right? Like I said, this works a lot. It doesn't work every time, but if you just calculate something, think, if I calculate a voltage, think KVL, it's going to help me on the next step. Or if I just calculate a current, think KCL. Okay, so I just calculated a voltage, so let's look at KVL. So if I go from C to D, I have to go up 4.9 volts. If I go C to D this way, I go up 3.28. What gets me to 4.9? 1.62, doesn't it? Right? So by 1.62 volts, and I got that by KVL. I could also use V equals IR, right? V equals IR to come up with 2 times 0.82, which is 1.64. Why do those not agree? Rounding. It's just rounding. Okay? So if you're a KCL fanatic or KVL fanatic, you'll choose 1.62. If you like V equals IR, you'll choose 1.64. If you see a difference like that, and it's small, I'm not saying 2 volts, I'm talking rounding errors, you did a fantastic job on the circuit and move on. Okay, pat yourself on the back, put the circuit master hat on straight, and you're all set. Okay? It's just a rounding error. Don't get uptight if you find a little thing like that. I just chose to do this and then this, right? I could have easily done this first, and then this would have been where I was showing my rounding error. I'm not going to get on you about that. Nobody will. It's just rounding. Okay? So questions on that? Switches provide us with 1 circuit to draw, but you with 2 problems. They're twofers. Teacher twofers. Okay? Any questions conceptually on what's going on there? Okay? Good. Excellent. So go ahead and get going on your homework. I'll tidy up a few things, and then I'll come walking around and give you guys a hand. Okay? Yeah, you got to draw a different circuit. You can't use the same one. You got to redraw the circuit completely. You can't do the teacher trick. Okay?
But doesn't that also be in the... Oh, because it's there.
Yeah, because you can go from C to D this way, but you can also go from C to D this way. So they have to have the same But I wasn't sure how we can tell. Oh, let's do it. Just do it. Because you don't. Oh, doing this. You don't. Okay. And then the direction that I see knows, is that the voltage or the gate? So the voltage arrows always go toward the positive side. They're always go to the positive side, but then the current arrows are always going not to negative, because this one goes up actually. Yeah, this one. Yeah, so like in this situation, the high voltage is like it's coming from this way, so but then when you're over here, it's like it's going back up this way, so that's why that arrow is.
So which way is it based on how many actually
Sir.
I'm looking at number 2 and it says VAE.
Uh-huh.
But there's no E.
You just don't see it.
Yeah.
You see it?
No.
Neither do
Oh. So is it just like a get a lot of students who turned into homeless?
I didn't even ask. Did you take one for your
My
dad?
dad looked at it, he laughed, he said, "Do it."
Oh, good. I'm glad. All right. That's different than most parents.
No,
Well, I-
because, and then like, cause he just started blurting out all the answers. Like, how are you doing that?
yeah, yeah.
Like 8 volts, 2 amps.
Is he a double E?
Yeah,
That's why.
he said, like, I
They do that
literally
stuff
do
in their
this.
sleep.
He's like, I literally do this every day. You can't just come to me.
That's funny. So he doesn't want to do it for fun.
My mom spent 45 minutes telling me about it at dinner.
Did you really?
Yeah.
You were talking about physics at dinner?
Yeah.
Oh my
Okay,
God! And you're admitting it?
Yeah. Okay, so my dad, I don't know, we had like a nice family dinner last night, and my dad was like, "All right, Dana, tell me 3 things about your day." And usually I'm like, nothing.
That's just like my kids were.
Yeah. And today I was like, nothing. Oh wait, I actually have something to say because both of my parents are engineers, and so, well, my mom, she hasn't worked since I was alive, and so she was just like all over this.
Was she
I didn't
really?
have
Oh, that's so,
homework.
is she an electrical engineer?
Yeah.
Oh, yeah.
I didn't have homework, and I didn't even like bring my homework upstairs. But she started like drawing practice ones, and she was like, "Well, do you understand this? Like, this is 0 at the bottom."
What did I tell you? Did you laugh and say, he told me that? Here, give that to her. Give that to her. That's so funny. Right?
Yeah.
That's so funny.
It like helped me because then I went downstairs and did my homework, and I was like, "Oh yeah." Okay.
That's right. Yep.
Thank you.
My wife and I are engineers, right? So my kids were the same way. They bring, what'd you do? That was about math and science.
I had a friend whose parents did the homework.
Did they? This homework?
I asked him, do you like circuits? He's like, yeah, I just asked my dad to do it.
And he did. Yeah.